Okay, all waveform must be either in cosine function or sine function. Okay, so you need to make sure that these three conditions are met before we compare the waveform. Okay, so right now, as you can see, this voltage and current. Okay, so as you can see, the frequency for both waveform are the same. Okay, 314. This one is your angular frequency actually. Okay, omega, which is your angular frequency. So make sure that your frequency or angular frequency must be similar. So as you can see, these both signal are similar. Okay. The second condition, the amplitude must be positive, and as you can see, the amplitude for both waveform are positive. And then the third condition, this waveform must be both either in cosine or sine function. But as you can see here, the voltage are in cosine function, but the current is in sine function. So you need to either convert this cos function into sine or this sine into cos. So I think I want to convert cos into sine. Okay. So Vt convert into sine function. So how to convert the cos into sine?
Minus 90?
Yeah, by using trigonal, right? Trigonal function. So actually, cos omega t is equal to sine omega t. Is it minus? Is it actually positive?
No, positive.
Yeah, positive 90. Okay. So to convert cos into sine is actually cos omega t is equal to sine omega t. So this Vt, so this is the magnitude, and right now the cos is right now sine 314 t plus 90 minus 120, right? So you will have 50 sine 314 t minus 30 degrees. Okay, that is the Vt after you have converted into a sine function. Okay. So the first question, sketch the waveform for Vt and It. So right now, both waveform are in sine function. Then we can actually sketch the waveform in time domain. Time domain meaning that this is the amplitude and this is your time. Okay, this is time. Okay, so you can plot. So for example, the Vt is this one, 50 sine 314t minus 30 degrees. Okay. So right now, what is the frequency? Okay. So 2 pi f is equal to 314. So your frequency is 314 over 2 pi. So by using calculator, do you see the calculator right now? Can you see the calculator?
Yeah, we can, doctor.
Yes, doctor.
So 314 over 2 shift Okay, so you will have, so your frequency is actually around 50 hertz. So 50 hertz meaning that your period is 1 over frequency, which is 1 over 50 hertz, which is your period is 20 millisecond. Okay. So my waveform. So how can I sketch my waveform? So as you can see, this is 50 sine 3140 minus 30. Minus 30 meaning that your phase, your angle phase is actually go here, delay by negative 30 degrees. Okay. Sorry, I think just put delay by 30 degrees. So meaning that your waveform will start here. Okay. And your period, you need to sketch this one. You need to actually put all the label. Okay. So this is your 20 millisecond, your period. Okay. So this is your VT. Okay. And what about your IT? So your IT is 30 sine 3140 plus 20, meaning that as you can see here, this is plus 20, meaning that your waveform is actually your current start positive 20, meaning that it start earlier, 20 degrees earlier. Okay. The frequency is the same. Okay, the frequency is same as you can see here. So the frequency is same, 50 hertz, meaning that your period is also same, which is 20 millisecond. The only difference is the magnitude and the phase different. Okay, and the phase angle. So this is negative 30, delay by 20 degrees, and your current is actually leading by 20. Okay, so I can sketch my waveform. So my waveform of the current is 30 angle. So just, okay, like that. Okay, so this one should be, you need to label. This one is 30. So this one should be higher than that, 50. Sorry, my draw is not very perfect. Okay. Okay. The second, so this is the first question. Okay. The second question is calculate the phasor for VT and IT. So actually, calculate the phasor is actually the different, the angle difference between this waveform, voltage waveform, and the current waveform. So the phase difference is actually this, from here to here. So what is the phase difference? How many different phase? Angle different.
sir.
Yeah, 50 degrees. Okay, so this one is actually 50 degrees. So the difference between this phase is 50 degrees. Okay. And then draw the phasor diagram for VT and IT. Okay. So actually, please. Okay. So if you draw, if you write down the voltage and current in the phasor domain, so your voltage should be like this. So V is equal to the magnitude only, 50, and the angle. The angle is actually negative 30 degrees. And the current, okay, the current is 30, angle positive 20 degrees. So this is actually the voltage and current in phasor domain. Okay. Right now, the third question, draw the phasor diagram for V and I. Okay, so this one actually we have discussed last week. Okay, so sketch about the voltage. So right now the voltage magnitude is 50, the angle is negative 30, meaning that the angle is down here, negative 30 degrees. So this is your voltage, okay, and your current is actually positive 20 degrees. So meaning that you go here. So this is your current, okay. So from here, you can clearly see the phase difference between V and I is 50 degrees, right? The phase difference. So that is for question number 3. And question number 4, calculate the impedance, which is your Z, and state the possible element in the circuit based on the impedance Z. Okay. So your V is your V is 50, negative 30, and your current is 30, 20 degrees. So your impedance is actually V over I, okay? Your impedance is actually V over I. So right now, we just put here negative 30 over 30, 20 degrees. Okay, you can use just calculator. Make sure that you select mode complex first. Okay, and then just type 50, and then the angle shift here, and then negative 30. So negative 30 over 30 angle shift 20. Okay, so and then just click here. So it will give you the answer in rectangular form. So 1.07. And then to get the imaginary part, shift equal. So you will have the imaginary part, negative J 1.28 ohm. Or you can directly convert into a polar form just by click shift and plus. Okay, you will show, it will show this display, and then just click equal. So it will give you the value. So this is the magnitude 1.6 with an angle of shift equal. So negative 50 degrees. Okay, but usually for the impedance, we always write down in terms of rectangular form rather than in polar form. Okay, we are much more prefer in rectangular form. Okay.
Sir,
Yeah, sorry.
what if we write the answer in polar form?
No
If we
problem.
deduct the marks?
No,
problem,
no,
okay.
no, it's okay. It's okay.
Okay, okay.
Okay. So from here, what you can see, this is your R, right? The first element is your resistor, right? And your second element is your, what is X? What we call this X? Resistor is resistor. X is what?
Capacitor.
No, no, no.
Mm.
We can either have positive or negative JX, right? JX. So what is X? We call what in general? React. reactance.
Reactance.
Yeah.
Something.
You need to memorize this. You need to remember this. Okay, in AC circuit, we have resistor and reactance. And this reactance can be either positive or negative X. Okay, positive X is inductor, negative JX is
Capacitor.
capacitor. Okay, so right now, your reactance part is positive or negative?
Negative.
Yeah, negative. Meaning that your impedance here consisted of a resistor and
Capacitor.
capacitor. Okay, so state the possible elements. So you can state the possible element referring to this impedance. You can say that the elements inside this box contains a resistor and also a capacitor. It depends on the impedance. Okay. Okay. This is actually one example of final exam questions from the previous years. So maybe you can have some what I call glimpse on what should be us during your final exam. And I would like to mention again that your final exam will be online, okay?
Okay.
Throughout this semester. So we will have class online throughout this semester. Your final exam also in online. Your lab also will be conducted online.
Lab.
Yeah, lab. I don't know your faculty, but our faculty has we start next week online lab.
We don't have lab for certificates.
Huh? You don't have lab this semester?
Yeah, we don't have lab. No,
Okay,
no.
so very lucky for you. Okay, so time is almost up. Okay, I want to discuss one more questions. Okay, so we end this meeting first, and then after 5 minutes, then we continue with the another questions. Okay.
Okay, doctor.
Okay.
Doctor, or
Okay,
another one?
doctor.
Okay.